All right, welcome Algebra Prep to our Unit 4, Topic 7 notes. It's the last set of notes we're going to take on a new topic for the year, so yay. So I'm going to put up here, Unit 4, Topic 7. And Topic 7 is going to be solutions to linear equations. So, solutions to linear equations. All right, so this is what we're going to be talking. And specifically today, we're going to talk about being able to algebraically prove or disprove if a point is on a line. So solutions to linear equations. So a solution to linear equation is every point that is on the line. So let's go ahead and make a note of that. So solutions to linear equations are every point that lie on the line. Okay, why does this keep moving? All right, so solutions to linear equations are every point that lie on the line. So and those can be whole numbers, those could be decimals, those can be fractions, right? Remember, a point is listed as x comma y, right? We list it as that ordered pair. So when we start talking about solutions, we're talking about the ordered pairs or the x comma y or the points that lie on a line. Let's change this to red here. All points on the line, right? We're talking about all the points. So when we start talking about solutions, we want every single point that is on the line is going to be a solution, right? So solutions to linear equations or linear functions is every single point on the line. So what we're going to do right now is we are going to algebraically prove solutions. So here we go. So let's go ahead and write down what we're going to do this. So algebraically, my A's don't look very much like A's, sorry. Algebraically, let's see if we can fix those. So algebraically proving solutions. This is what today's notes are all about. And so to algebraically prove solutions, we're going to substitute the values for the ordered pair, that x comma y, into the equation and solve to see if it's true. So this is what we're going to do. We're going to substitute the values for the ordered pair, which is the x comma y that we talked about up above, right, into the equation. So into the equation and solve, to see if it's true. All right, so we're going to algebraically proving solutions is substituting the values for the ordered pair, that x comma y, into the equation and solve to see if it's true. And I'm going to make a note here, right, so that if it is true, then we say equals a solution. That means that the point is on the line. So point is on the line, right? So if it's a true statement, then it is a solution and the point is on the line. If it's a false statement, so if you end up with something that's false, that means it's not a solution, or the point is not on the line. So point is not on the line. So this is what we're going to do. We're going to plug in our values for our x and y into our equation, and then we are going to solve and see if it's true or not, to see if the point is on the line or not, and if it's on the line, it's a solution. All right, so let's do this. We're going to do 3 examples of this. So let's go to another page here. Let's write down number 1. All right, so number 1, here's my problem. Y equals 4x minus 1. So here's my linear equation. It's in slope-intercept form, right? Y equals 4x minus 1. So we're going to take some points and, and test them to see if they're true. So here I'm going to put a little a under here. We'll test 3 different points for this one. My first point we're going to test is 2, 7. So there's my ordered pair. The 2 is my x value. So it's going to go in for that x that I just made red, and then I'm going to make my y green, right? So the 7 is y. That means we're going to take this y out and replace it with the 7. So I'm going to rewrite the y equals 4x minus 1 with 2, 7 in place of xy. So that means we're going to start with a 7. So we have 7 equals 4 times the 2, because it's 4x, and then minus 1. All right, so now I have a problem on the right-hand side. We have math we have to do. All right, so this should look a lot like when we were checking our solutions or checking our answers for solving equations. Right, 4 times 2 is 8. Order about, we do the multiply first. 8 minus 1 is 7. 7 equals 7 is a true statement. That means the answer is yes. This is a solution. So 2, 7 is a solution. It is a point on the line for y equals 4x minus 1. Okay. All right, let's try another one. So we got B. So let's try the point -3, 11. Right, so the -3 is my x. The 11 is my y. So this equation, we'll start with the y. So I have y, 11, equals 4 times that -3. And then we're going to subtract 1 from that, right? So we plugged in 11 and -3 for x and y. And then we're going to do the math. So 4 times -3 is -12 minus 1. Keep change switch. -12 plus -1 is -13. 11 does not equal -13. That means that this is not a solution. The point -3, 11 is not on the line. Y equals 4x minus 1. All right, let's try one more. So C. What if we do a point with a fraction, right? We said points don't have to be whole numbers, or the xy coordinates don't have to be whole numbers. So we have 1/2, 1. So here's my point that we're going to test. So the x is 1/2, the y is 1. So my equation is going to be 1 equals 4 times that 1/2, and then we're going to subtract 1, right? That part all stays the same. We're just plugging in the different x and y values. So I'm going to put 4 over 1 times 1 over 2 minus 1. 4 times 1 on top is 4. 2 times 1 is 2 on the bottom. Subtract that 1. 4 divided by 2 is 2 minus the 1. 2 minus 1 is 1, right? We should go all the way down to a single number and see if it's true. In this case, 1 equals 1 is true. That means that the point 1/2, 1 is a solution, is a point on the line of y equals 4x minus 1. All right, that's the first problem down. I'm going to do 2 more. So 2. All right, so what if we do one with a slope that's a fraction? So we have y equals -1/2 x plus 3. All right, let's test a couple points on here. So first point we're going to test is -4, 1. Right, so the -4 again is my x. I'm going to go ahead and box that x and make that red. The 1 is going to be my y right here. So we're just going to plug in to this equation and check it. So I have 1 equals, I'm going to do negative 1 over 2. I'm going to put the negative on top, times, I'm going to go ahead and make that negative 4 a fraction, so negative 4 over 1 plus 3. All right, so multiply straight across the top, multiply straight across the bottom. Negative 1 times negative 4 is 4. 2 times 1 is 2. Plus 3. 4 divided by 2 is 2. Plus 3. 2 plus 3 is 5. 1 does not equal 5. That means the point negative 1, 4, or negative 4, 1 is not on the line. It's not a solution. All right, let's try another one. B. Let's try 8 comma negative 1. So here's my ordered pair. Make sure you put parentheses around that ordered pair. Right? The x value is 8. The y value is negative 1. So starting with the y, I have negative 1 equals negative 1 over 2 times, put that as 8 over 1, so I'm multiplying it by a fraction, and then we're going to add 3 to that. Right? So I have negative 8 on top. 2 times 1 is 2 on the bottom, and then plus that 3. Negative 8 divided by 2 is negative 4, plus that 3. Negative 4 plus 3 is negative 1. That is what we needed. That means the point 8, negative 1 is on the line. So it is a solution. The answer is yes. All right, one last problem, or one last ordered pair for this problem. So let's try negative 6 comma 6. Right? So negative 6 is x, positive 6 is the y. So I have 6 equals negative 1 over 2 times negative 6 over 1 plus 3. So multiplying straight across the top, I have 6 over 2, because negative 1 times negative 6 is positive 6. And then we're going to add that 3. 6 divided by 2 is 3. 3 plus 3 is 6. So 6 equals 6 is true. That means the point negative 6, 6 is a solution to y equals negative 1/2 x plus 3. It is a point on the line. All right, let's do one more. Most of the stuff we have been doing this unit has been in slope-intercept form, right? Y equals mx plus b. If you look up here at the top, right? Y equals mx plus b. That's the form. Now we're going to do one problem. It's going to be in what we call standard solution, or standard solution, a standard standard form. So standard form says ax plus by equals c, where the x and the y are on the same side. So here's an example of a linear function in standard form. So I could have x minus 2y equals 8. When we're doing solutions, we're going to be working on it the same way, the same idea. So let's start with a point that we're going to check. So I have a point 0, 4. Right? So again, the 0 is my x. This time my x is here on the left. The 4 is my y. The y is over here by this negative 2. So now we're going to fill in. So since the x comes first, we're going to put the 0 first. So I have 0. And then I have minus 2 times the y, which is 4, equals 8. By order of op, we do this multiply first. So we have 0 minus 8. And then 0 minus 8 is negative 8. Negative 8 does not equal positive 8. So this point is not on this line. 0, 4 is not on the linear equation x minus 2y equals 8. All right, try another one. Try another point. So here's B. B, we're going to put some decimals in B. So let's do it at 2.3, comma, negative 2.85, right? I said they could be whole numbers, they could be fractions, they could be decimals. All of these are points, and they could be on the line, or they may not be on the line. So 2.3 is x, negative 2.85 is y. So we're starting with the x in this problem. I'm going to start with 2.3, and then we're going to subtract 2 times negative 2.85, and that whole thing, we're going to see if it equals 8. Right, so this is what we're testing. So multiplying negative 2 times negative 2.85, that is a positive 5.7. So we bring down 2.3. We're going to add to that 5.7. 2.3 plus 5.7 is 8.0. And we want to know, does 8.0 equal 8? The answer is yes. Right? 8.0 is the same thing as 8. So that means the point 2.3, comma, negative 2.85 is on the line. X minus 2y equals 8. It is a solution. It would be hard to, if you just saw the line, it would be hard to pull that point out because it's not at grid marks, but it's still a point on that line. Remember, every single point on that line represents the entire line. All right, one last one. Let's do C here. What if we try negative 10, comma 9, right? So x is negative 10 and y is 9. So starting with the x, we're going to start at negative 10 minus 2 times this 9, and we're going to see if it equals the 8. Right, order of op says we do this negative 2 times 9 first. So that's negative 18. So I have negative 10 minus 18. And then if I do keep, change, switch, I keep negative 10, change it to addition, switch it to negative. That means this is negative 28. Does negative 28 equal 8? The answer to that is no. All right, make sure you do that keep, change, switch because you might have been tempted to get 8 as an answer if we did not keep, change, switch that correctly. So the answer is no. Negative 10, 9 is not a solution. It is not on the line. X minus 2y equals 8. All right, that's the last topic, topic 7 for unit 4. So come to class on Wednesday. We'll do some practice on this and on the table, graphing from the table that we did in topic 6. See you Wednesday.